Now that we've got the sine and the cosine defined, remember on the unit circle, the sine measures the distance from measures the vertical component, and the cosine measures the horizontal component. We can define four more functions that are important for us in certain cases. The first two are the tangent and the secant. And to get the tangent and the secant, here's what we do. We draw a tangent line. Tangent just means to touch. So I'm going to draw a line that just touches the circle. I'm going to make a vertical tangent line. So if I draw a line here, hopefully that looks like a vertical line, that's just touching the graph there. So it's a tangent line. And I have some angle, so it's in standard position. So the initial ray is along the positive x-axis, and then the terminal ray is maybe over here somewhere. Then I can look at where that terminal ray crosses that tangent. So one distance that's of interest would be this one. This is actually, so we have alpha, which on the unit circle, that's the distance along this arc, right? That's this arc length on the unit circle. There's alpha. Here's the tangent of alpha. And the other distance that's of interest is how far from the center does this terminal ray intersect that tangent line. That distance we call the secant of alpha. Now, if you look at this, we already know about the cosine of alpha, right? The horizontal component, and the sine of alpha. That's the vertical component here. Right? So if you look at these two triangles, they're similar because they both have a 90-degree angle, and they both share this angle alpha. So that means these angles have to be the same. So if two triangles have all the same angles, they must have the same shape, just possibly different sizes. So these triangles are similar. Now, one thing we know about similar triangles is that ratios of corresponding sides are the same. So for example, if I take the ratio of this upright side to the horizontal side on the big triangle, that would be that since this is the unit circle, this length is equal to 1, right? The cosine is just that length there. So if I take the tangent of alpha divided by 1, that's the length of the vertical to the horizontal, that's the same, that ratio will be the same as this ratio on the smaller triangle, which should be the vertical over the horizontal. So this tangent of alpha is actually the sine divided by the cosine. We can do something similar for the secant. Let's look at the ratio of the hypotenuse to the horizontal. So for this big triangle, the hypotenuse is the secant of alpha, and the horizontal, that's that whole distance along the unit circle, so that's 1. That's equal to the ratio of for the small triangle, the hypotenuse to the horizontal is 1 over the cosine of alpha. So the secant of alpha is actually 1 over the cosine of alpha. So you probably had trig before, and you probably memorized that these ratios define the secant and tangent. And this is the explanation for their names. Right? The tangent is where does the terminal ray intersect that tangent line. Right? So what's this component? And the secant gives you this distance basically from the origin to where you hit that. Secant means to cut, and you can see that this ray cuts through the tangent there, so it cuts through the circle as well. So that's why it's called the secant. So you need to have those two ratios defined so that you can work with tangent and secant in terms of sine and cosine. You need to have those two ratios memorized so that you can do that. The other two are sort of companions. Instead of using a vertical tangent line, you can draw a horizontal tangent line here. So here's our horizontal tangent. Unfortunately, it's not quite touching. It should have been. So let's take our, maybe I need to extend that a little bit further. Let's take our any old angle. Here's our angle alpha, right? And this is the unit circle, so that length is 1. And we'll define this component. This component here is going to be the cotangent of alpha. So how far along does this secant here, this terminal ray of our angle, intersect this horizontal tangent? That's the cotangent. You can see the cotangent will be different from the tangent in many cases, because if you think about it, the tangent is where does that line intersect this vertical one, right? So the tangent could be small when the cotangent's large, and so on. Okay. And the other one would be, and you guessed it, that's the cotangent, right? This one, or the cosecant, because this one was the secant before. Now, if we look at this whole distance, that's going to be the cosecant of the angle. So we abbreviate cosecant by CSC. So if we use similar argument here with similar triangles, the cotangent of alpha turns out to be the same, the ratio of the cotangent to, so the horizontal to the vertical, that would be the cotangent of alpha over 1. That's the same as the ratio of the horizontal to the vertical, which on that unit circle, this is the cosine divided by the sine. So cosine divided by the sine. And for the secant, or the cosecant, sorry, the cosecant is 1 over the sine. Same similar triangles argument tells you that. So in particular, you'll notice that the cotangent is actually, the tangent was sine over cosine, so this is the reciprocal of the tangent. So the cotangent is the reciprocal of the tangent for an angle. These are basic trigonometric ratios that you have to memorize so that you can work with them easily. So the cotangent is the cosine over the sine, and the cosecant is 1 over the sine. So the tangent and the secant come from using a vertical tangent and measuring these things, and the cotangent and the cosecant come from using a horizontal tangent there.